Now, let's solve this given differential equation. We have here an equation already expressed with differential operator d, and this would be our dependent variable. And it is said to have imaginary roots later on in connection to the auxiliary equations. Now what we're going to do here is to transform this into its equivalent auxiliary equation. In short, you will have here 2m to the power of 4 plus 11 m cubed minus 4m squared minus 69 m plus 34 is equal to 0. So we have a quartic equation, and there are a lot of possibilities here. Hence, the rational root or rational zero theorem may not be our best option here. So we need just to think of possible numbers that are possible. When substituted here, will resolve this entire equation to 0. Of course, you can always try 1. If it's 1, you will have 2 times 1 to the power of 4 plus 11 times 1 cubed minus 4 times 1 squared minus 69 times 1 plus 34. Let's see if this is equal to 0. 2 plus 11 minus 4 minus 69 plus 34. This is too large, and definitely it's not possible. Okay, this is not possible. So let's try another number. Let's have negative 1. 2 times the fourth power of negative 1 is positive 1 plus 11 times the cube of negative 1 is negative 1 minus 4 times 1, that's the square of negative 1, minus 69 times negative 1 plus 34. Let's find out if this is equal to 0. But to cut this short, this will become positive 69 plus 34. That's too large already. This can not neutralize that. So again, it's not possible. You simply try as much as possible numbers. Of course, you could proceed to your P over Q, the rational root or rational zero theorem, where you will take the factors of 34 here for P. So that's plus minus 1, plus minus 2, plus minus 17, plus minus 34. And then the factors of leading coefficient 2 with your Q, so plus minus 1, plus minus 2. But that is also too many to try. So let's simply continue with this process here. Let's have 2. So you have 2. The fourth power of 2 is actually 16 plus 11 times 8 minus 4 times, you have here 4 minus 69 times 2 plus 34. Let's see if this will result to 0. This is 32 plus 88 minus 8 minus, correct me if I'm wrong, 138 plus 34. Is it equal to 0? This is actually 120. Sorry, my bad. This is where I get it wrong. 16. 120 plus this is 154. This is negative 154. And yes, 2 is a root of this given auxiliary equation. Hence, our first factor is m minus 2, where c is 2, which we'll be using in later here on our synthetic division to look for the other factors. So you have here 2, 11 minus 4 minus 69, positive 34, and your c is 2. That's your first root. So you have 2 here. 2 times 2 is 4. That's 15. Times 2 is 30. You will have 26 here. Times 2 is 52. Yes, this is negative 17 times 2 is 30, minus 34, 0. This is an indication that this is really a correct root. So you have a 0 remainder. To continue, you will have a cubic equation 2m cubed plus 15 m squared plus 26 minus 7, plus 26m minus 17 is equal to 0. The same thing will happen. We still need to look for possible factors, and so on and so forth. Let's look into this one here. If you're going to try 1, if m is 1, that's 2, 1, that's a cube of 3, cube of 1 rather, plus 15 times 1. These are all positive. That's too large, so it cannot happen here. Okay, it's not possible. Now, what if we try certain fraction? What if I will try 1/2? Just for the purpose of discussion. So you have 2 times the cube of 1/2 is 1/8. Okay, plus 15 times the square of 1/2 is 1/4, plus 26 times 1/2 minus 17. Just introducing fraction because they are also possible here. So you have 2 times 1/8 is 1/4. Here you will have 15 over 4ths. Okay, that would become an integer, so it's interesting here. Plus you will have 13, that 26 times 1/2 minus 17 is equal to 0. This is 16 over 4, which is just equal to 4. Yes, so 4 plus 13 is 17, and then you will have here minus 17, and then that's correct. This is actually another root here. So we have two real roots now, 2 and 1/2. But here, it was stated that they have imaginary roots. So if there are some instances where it's not given, it's not stated, so do not assume. But here, let's try to move further because it's still possible here. And now, notice that your synthetic division will include C, which is fraction. So you have 2, 15, 26, negative 17, and here you will have 1/2. Okay? That's because that is your root here. So 2 times 1/2 is 1. You will have 16 times 1/2, you have 8. This is actually, 34 times 1/2, you have 17, 0. Yes, that's correct. Okay, surprisingly, our value of 1/2 is correct. Now, let's move further here. You will have 2m squared plus 16m plus 34 is equal to 0. Okay, this is not a quadratic equation, so let's use here the quadratic formula. But first, you could always factor out 2 to make it simpler. M squared plus 8m plus 17 equal to 0. Dividing both sides by 2, so you will have this form of your equation, which is actually simpler as you will try a quadratic formula. In the previous videos, we've been trying completing the square. We can also do that here, but in this case, they just simply use the quadratic formula to also try this. Quadratic formula, m is equal to negative b plus minus the square of b squared minus 4ac all over 2a. Your a here is 1, b is 8, c is 17. So you have minus 8, that's negative 8, plus minus the square root of 8 squared minus 4 times 1 times 17. Okay? 2 times 1. So this might be a little bit difficult in this time. I'm just trying to continue this. Negative 8 plus minus, we'll have 64. That's 34 times 2 is 68. So minus 68. So 2. Because 17 times 4 is 68, if I'm correct. So you will have here negative 8 plus minus the square root of negative 4 over 2. Okay? I don't have much space. Hopefully, I could finish here in this area here. So you have m is equal to minus 8 plus minus 2i over 2. Factor out 2. You will have 2 times negative 4 plus and minus I over 2. So your imaginary roots, and yes, we have imaginary roots here. You have negative 4 plus minus I. This is using quadratic formula. I believe it's still the same if you will use the completing the square method here. So we have two imaginary roots. We have imaginary roots. We also have real roots 2 and 1/2. So we will combine here the general solution for those real, distinct real, and imaginary. For distinct real, this is our solution. C sub 1 e to the power of your first root. Your first root is 2. Please be guided. The second root is 1/2. So you will have here 2x plus your second root, c sub 2 e to the power of 1/2 x. Okay? 1/2 x. Plus, you will now integrate the solution involving imaginary roots. You will have here e to the power of ax. This is your a, plus minus bi. So your b is 1, your a is minus 4. So you will have here e to the power of negative 4x. Let me rewrite it here because it has trigonometric functions. E to the power of negative 4x times c sub 1 cosine, your b is 1, so cosine 1x or cosine x, plus c sub 2 sine x. So combining this, these are for distinct real roots, these are for your imaginary roots. Bottom line, the entire equation here is our solution for the given differential equation. Thank you very much for watching.